In this video, we're going to work through a line segment addition postulate example question, and it's going to be based on the Lego build that we have here. The situation we're given is that the farmer is building a fence across a small crop, but has run out of fence panels. He doesn't have a tape measure with him and needs to determine how much fencing is still missing before going to buy more supplies. So this is the missing portion of the fence right there. And then we're given some length information. We're told that the portion of the fence on the left side of the gap has a length of 12 feet. And then the portion on the right side of the gap has a length of 34 feet. And then the total length that needs to be fenced in is 62 feet. We're also told that the figure is not to scale. Then we're given a task list that has 3 items on it. So first is to draw a line segment model of the situation and label all the points and lengths, and it doesn't have to be to scale. The second is to write an equation that represents the total length of the fence. And then the third is to actually solve for the missing length of the fence. Let's start with that first task. So we're going to draw a line segment model of the situation, add in our labels for points and lengths. I'm just going to draw a straight path to start with. When I look at this situation, it looks like we kind of have 3 separate line segments that are connected. So the fence here is kind of like one line segment, the gap is another, and then this remaining portion of the fence is a third. I'm going to add some points to separate those into the model here. I'm going to start by using a point labeled P, but you could choose any letter that you would like. So we'll start off with this. We'll start at point P, and then we'll have it go to point Q here. So then Q will act kind of as the starting point as the next one as well, and then I'll have that gap end at R. And then again, R will kind of be the starting point here, and then we'll have the whole thing end over here at S. All right, let's add those points on into our drawing. So we'll start with P and then label this end with S, and then add in labels for Q and R. Next, let's put in the lengths. The left side is 12 feet. We don't know the length of the gap. And then the right side is 34 feet. And then the whole thing here is 62 feet. So different instructors, different classes are going to have different levels of requirements when it comes to putting the units on things. So in the diagram, I'm just going to put in the feet symbol for everything, so we know that everything has the same units. All right, and the last thing we don't have a length label on is QR, so that's our unknown, so we can label it with X, like you would in algebra, or another variable if you'd like. So our first task is complete there. Let's move on to the second one. Here, we're going to write an equation that represents the total fence length. So if you remember, there's an equation with a line segment addition postulate, but the thing that is more important to remember is that it is saying that when you have a line segment that has separate parts, you add up the lengths of each part, and that will give you the length of the whole thing. So we can make our own equation knowing that information. We know that this plus this plus this, when we put that all together, that has to equal the whole thing because you're adding all the parts together. So let's write that out as an equation. So it would be PQ plus QR plus RS, and that would equal PS, the whole thing. All right, for the last task, we are going to actually solve for the length here, and we're going to use the equation that we built to do that. So let's write out the lengths of each segment. So line segment PQ has a length of 12. Line segment QR has a length of X. Line segment RS has a length of 34. And then the whole thing, line segment PS, has a length of 62. Now let's plug all of these into our equation here. So PQ is 12 plus QR, which is X, plus RS, which is 34. And that all equals PS, which is 62. Let's combine like terms on this side. So we're going to have X plus 12 plus 34 equals 62. We add 12 and 34, and that is going to give us 46. So X plus 46 equals 62. We subtract 46 from both sides. Oh, sorry. This will go to 0. And then 62 minus 46. So we're going to have to borrow 1 from here. 12 minus 6 is 6. 5 minus 4 is 1. 16. So we get that X equals 16 feet. So we add 16 feet here, and the fence is complete. Key thing to take away here is with the line segment addition postulate, it's very helpful and when you need to find the length of something when you only know the parts, or if you know the length and some of the parts and only one missing piece, you're able to solve for that missing piece. In our next video, we're going to learn what it means when line segments are congruent.